Hey guys, welcome to another video for Algebra 2. In this video, we're going to be working out one of the worksheets in your lesson here for 2.4. In this lesson, we're going to be sketching graphs based off of some of the information that you're being given. Okay, so let's go ahead and get started. So this is the lecture for 2.4. So you'll want to take notes for this, and these are the notes that you'll turn in for credit later on. Okay, so let's go ahead and jump in now. So I'm looking at this worksheet here. Now, if you look at the top part of the worksheet, this gives you a lot of information that describes the behaviors of the graph, and you can go ahead and read through that on your own. And what I'm going to do is that I'm just going to go ahead and work out some of these problems so you can see how it corresponds. Now, all of these terms you should be familiar with. Like for example, I'll go ahead and just look at a few, like the x-intercept. The x-intercept is the x-coordinate of the point where the graph crosses the x-axis, right? And the one that you're very familiar with is the y-intercept, which is the y-coordinate of a point where the graph crosses the y-axis, right? And all these other terms that are below that we've discussed from 2.1 to 2.3 in one time or another, and we will be discussing those again as we continue here. Okay, so let's look at the practice one right here first. Let's look at this practice one. Okay, so it's saying use the given key features, okay, the features above that we just looked at, to sketch a linear graph. Okay, first of all, it just told me linear. Well, it already gives me the answer here, right? It shows me that it's a linear graph. But let's confirm that with the information that's given so you can see how it's used. So the y-intercept is -4. So here's the y-intercept, -4. So that's 1 point. The function is positive for x greater than 5. So I look at my x-axis, right, and I see where 5 is right here, and it's telling me that the function is positive at all points x greater than 5. So that can mean one of two things. That can be either a parabola going up, that's positive, right? Or it could be, as it's shown, a straight line. Now I can assume I can assume that it's a straight line because I've been given another point prior, which is the y-intercept here. So this is the first point, that's the second point. So then I know that it's a straight line, right? And of course it's easy here because it's already telling me it is. But what if you had to figure out what that line looked like on your own? Well, by looking at these 2 points, you can kind of tell that it's going to be a straight line. So let's keep looking at more information just to confirm all this. So as x approaches positive infinity, so I'm looking at the x-axis towards positive infinity, the function is positive. It goes to positive infinity. So as I keep increasing x's, so I have x is 6, I'm going to have a corresponding y, right? And my x is 7, I'm going to have a corresponding y that is greater than the previous. And let's say I pick x a billion, okay, I'm going to hit the line at some point over here, and then I'm going to have a corresponding y that's also very high. So as x approaches infinity, okay, my function, the behavior of the function is positive infinity also. It goes up also, right? So for every x that I increase, I'm going to have a y that's also increasing all the way to infinity. So it never stops, essentially, okay? So now let's look at the last piece. So as x approaches negative infinity, so now I'm looking at the x-axis going left, negative infinity, the function behaves, its end behavior is negative infinity also. So as my x's become less and less, right? Let's say x is 3, then I'm going to have a corresponding y that's going to keep getting lower and lower. So as x is 2, you'll notice that the y's get lower and lower. If I pick an x that's a negative negative billion or something, then it's going to have a corresponding y that's also going to keep getting lower and lower. Okay, so it got an end behavior of a negative end behavior. So this line that they gave me does confirm all the information that I was given on top. So now let's look at some of the ones that you're given here. Let's work out these three samples, okay? Okay. So the y-intercept is 2. So then I can look at my y-intercept and go to 2 and know that there's a point right there. The function is positive. for x less than 7. Okay, so I'm going to go to my x-axis over here, and I'm going to locate 7. So there's 1, 2, 3, 4, 5, 6. There's 7 right there. So that's my point. All right. So now I have 2 points. So I could essentially just draw my line right there, uh, and I would be done. But what I want to do, because we want to understand what's going on here, let's go ahead and confirm this. Right, and I'm going to confirm it by the information that's given. So it says as x approaches infinity, so as x approaches infinity, so as it keeps going to infinity, my function, the end behavior is negative infinity, which yes, in fact it is, because as I go to a positive infinity on the x-axis, my function is in fact going down, right? As my x gets bigger, my y is going to get smaller and smaller and smaller, right? Because I went from being here to down here, and then it's just going to keep getting lower. As the x gets bigger, the y will get lower and lower and lower all the way to infinity. Okay, and just for good measure, let's confirm the other side of this. Let me erase this, so let's confirm it. So here it is, as x approaches negative infinity. Oh, I erased my line. I need that. Let me go back to that. So what would it be? Right here. It's 8, 7. So there's my line, right? So as x approaches negative infinity, my function is behaving, it's going to positive infinity, and that is true. As my x gets smaller and smaller, my y's get bigger and bigger, right? So that y term is going to go all the way to infinity as my x goes to infinity, that function is. Okay, all right, let's do the next one here. Okay, so the y-intercept is 2, so there's my first point, and the function is positive for x greater than negative 6. So x greater than negative 6, 1, 2, 3, 4, 5. Okay, so my graph that they made me is too small, so I'm going to do it in increments of 2. So this will be negative 2, negative 4, and negative 6. So here's my second point. Okay, so that's my line right there, right? That is my line. So having said that, let's see. Let's confirm it. So as x approaches infinity, so as I'm going this direction on the x, my function is going positive, and that is true, right? So as my x is going to positive infinity, my function is going to positive infinity also, all right? So let's take a look now at the other side. So as x approaches negative infinity, now as I'm going this way, as x approaches negative infinity, the function is going to negative infinity also, and that is also true. So as I'm going to negative infinity, my function is behaving in a negative fashion also. So that confirms that. All right, let's go to the third one. Third one, not least. Okay, so my y-intercept is 1.5. So if I say this is 2, this is 1, so it's going to be right here, 1.5. Right? Okay, and then my function is positive for x greater than negative 3. So I can say this is negative 3, and my function will be positive. Okay, so it looks like this will bear out. Okay, so as x approaches infinity, the function goes to a positive infinity, and that does bear out. So far so good. Next, as x approaches negative infinity, as I go to the left, the function is negative, and that also bears out. Okay, so I hope these sample problems, and I hope you saw how we ended up using all these terms here, how these key terms are very crucial in describing and sketching out graphs. Okay, so so your job will be to do the the worksheet that will be handed out to you next also, and whatever you don't finish in class will be done for finished up for homework and turned in the next time I see you. Okay guys, good luck in your studying.